Hello friends, welcome to this lecture of soil science and technology, and in this lecture we will be continuing the soil classification, and we will continue from where we left in last class or last lecture. So, let us continue from that. So, in the last lecture we have covered what is soil taxonomy and what is soil classification, what are the different aspects of soil classification, and then what are different types of diagnostic horizons. And we divided the diagnostic horizons into major two broad categories. One is surface diagnostic horizons or epipedons, and we then discuss 8 different epipedons, and then we talked about the surface diagnostic horizons. We call them endopedons, and there are 20 endopedons we have discussed one by one. And then from today onwards from this lecture onwards we'll be discussing about different soil orders. So, before going to the soil orders, let us check a good slide which can show you, which can give you a basic overview of different conditions and which are required for forming different sub horizons or different subsurface diagnostic horizons or endopedons. Now, in this screen you can see that if the starting point is unweathered parent material, and different conditions are given here to which are required for formation of specific endopedons. For example, if there is no significant accumulation and if this is light colored horizon with some clay and iron remove, clay, iron and aluminum remove, then we call it albic horizon. And if it is weakly developed horizons and showing some color changes, we call it cambic horizon. And obviously, if there is an accumulation of silicate clays, then it goes to a new path, and you can see there is a due to the presence of high and low activity clays and clay skins evident, we can divide them into either argillic with high clay content, and also natric. The difference between argillic and natric is argillic contains less than 15% of exchangeable sodium, whereas natric contains by definition more than 15% of exchangeable sodium. So, you can see that all these subsurface horizons or endopedons are given here, and their specific pathway, the specific pathway which is responsible for their formation is also given. So, this slide will give you an overview of different weather conditions and different other conditions which are required for formation of those diagnostic subsurface endopedons. So, one of the important point of this soil taxonomy is that the soil classification is also based on different types of soil moisture regime and soil temperature regime. So, let us first discuss what is soil moisture regime. Now, soil moisture regime basically shows the wetness condition of the soil horizons for and their respective duration. So, the soil moisture regime, or in the acronym is SMR, can be divided into 5 different categories. The first one is aquic, which basically when the soil is saturated with water for sufficient period of time for evidence of poor aeration is there. So, in that case we call it aquic soil moisture regime. So, this aquic soil moisture regime basically you can find in case of waterlogged soils. And second most important soil moisture regime is woodic soil moisture regime, which is basically which basically characterize when the soil moisture is sufficiently high for year round in most years to meet the plant needs, and it is an extremely wet moisture regime with excess moisture for leaching throughout the year. and when there is an excess moisture for leaching throughout the year, then it is termed as parodic. The third one is called oustic, which is soil moisture which is intermediate between eudic and aridic. Now, what is aridic? Aridic is basically the soil moisture regime which you can see in the arid region. So, when the soil is dry for at least half of the growing season and moist for less than 90 consecutive days, then we call this soil moisture regime as aridic soil moisture regime. And the finally xeric, which is found in typical Mediterranean type climates with cool and moist winters and warm and dry summers. So, basically these five in a nutshell shows what are the important soil moisture regimes, and based on these soil moisture regimes soil taxonomy divide or we develop different classification criteria. So, you can see this is soil moisture. This is some pictures showing soil moisture regimes, and obviously you can see glaying is evident in this soil moisture regime, and which occurs due to the prolonged waterlogged condition, and this basically shows the aqueous soil moisture regime. Now, let us see what is soil temperature regimes. Now, soil temperature regimes are based on mean annual soil temperature, and mean summer temperature, and the difference between mean summer and winter temperature, all at 50 centimeter depth. So, remember that all these soil temperature regimes are defined at 50 centimeter depth from the surface. So, what are the important soil temperature regime? As we can see that at 50 centimeter depth, based on mean annual soil temperature in degree centigrade, we have classified the soil temperature in 6 to 7 different types of classes. So, as you can see from this screen, when the hypergelic, with the soil moisture regime is hypergelic, that means the mean annual temperature should be less than minus 10 degree centigrade. So, or minus 10 degree Celsius. When it is in between minus 4 to minus 10 degree Celsius, then we call it pergelic. And when it is within minus 4 to plus 1 degree Celsius, then we call it subgelic temperature. And craic is basically a temperature regime when the mean annual temperature is less than 8 degree Celsius, and frigid is also a temperature regime where the mean annual soil temperature is less than 8 degree centigrade. The difference between craic and frigid is the craic is characterized by cold summer, whereas frigid is characterized by warm summer. Now, another temperature regime is called mesic temperature regime, where the temperature lies between plus 8 to plus 15 degrees Celsius, and thermic regime basically characterized by plus 15 to plus 22, and finally hyperthermic, which is characterized by plus 22, that means more than 22 degrees Celsius. Now, remember that all these temperature regimes are basically characterizing when there is a more than 6 degrees centigrade. Sometimes you will find it is more than 5 degrees. So, all these temperature regimes are named when the difference between summer and winter temperature is greater than 6 degrees centigrade. And when the difference between the summer and winter temperature is less than 6 degrees centigrade, then this frigid is also named as isofrigid. The mesic will be termed as isomesic, the thermic will be termed as isothermic, and finally hyperthermic will be termed as isohyperthermic. So, this slide basically shows concisely what are the different types of soil moisture regime and how we name them and what are their different criteria. So, Let us see what are the different types of nomenclatures which are used for soil taxonomy. Now, there are 6 hierarchical categories of the soil taxonomy, as we have discussed already in the last lecture. So, the lowermost group is called the soil series, which is most specific. So, above the soil series there are soil family, and above the soil family we call it soil subgroup. There are 25,000 soil series which is identified in United States, and there are more or less 8,000 families of soil which have identified so far. There are 2,500 subgroups. Above the subgroup there is grade group around 444, and then suborders 68 suborders, and finally there are 12 orders. So, order is the highest category in the soil taxonomy. So, the lower categories fit within the higher categories, and obviously each order has several suborders, and each suborder has several grade groups, and so on and so forth. So, if you compare the if you compare the nomenclature or classification of a common cultivated, if you compare the classification of a common cultivated plant with a soil series called Miami series, then it is quite clear how we have given the, how we can name different soils. For example, you can see the plant can be classified into different a phylum, a class and subclass, order, family, genus and species. To up to species level, which is the most specific level, you can classify that particular plant. Similarly, a soil can be classified into order, suborder, grade group, subgroup, family, series. Now, up to series, these 6 levels are included in the soil taxonomy. The last one is not generally included in the soil taxonomy, but generally we use when you go for soil survey in the field. So, we will be only concentrating on these 6 soil classification levels. We can say it levels or hierarchical levels. So, you can see order, which is alphisols, and then suborder eudalphs, grade group is haplodulphs, subgroup oxyaquic haplodulphs, then family fine loamy, mixed, mesic, active, and finally series name. So, each soil can be described on the basis of these nomenclature in the soil taxonomy, and that is why soil taxonomy is always better than earlier morphogenetic systems of soil classifications. So, for example, let us see if there is a mollisol. We will discuss what is mollisol in a few minutes. Then let us start with the order, which is mollisol, and you can see suborder, which is aquols, and grade group, which is RG aquols, and subgroup, that is typic RG aquols. Why? What are the these indicates? We will discuss in a minute. Okay. So, let us see. Let us start with the soil order first. So, each of the world soil is assigned to one of the 12 soil orders. Remember that there are a total of 12 soil orders, largely on the basis of soil properties that reflects a major course of development, with considerable emphasis placed on the presence or absence of major diagnostic horizons. So, each order is characterized by the presence or absence of a specific diagnostic horizons, and we will see that from the next slide onwards. So, let us see, this is a compiled list, and you can see that we have listed here 12 different soil orders. For example, alphisols, then andisols, then aridisols, entisols, jellysols, histosols, inceptisols, mollisols, oxysols, spodosols, ultisols and vertisols, and each of them are characterized by a specific surface or subsurface horizon. For example, In case of alphisol, you will see that argillic, natric or candic horizon is present, whereas high to medium base saturation you will find. In case of andisol, these are mainly present in volcanic areas, and it is basically dominated by allophans, which is a kind of clay mineral. We will discuss them in details later on, and aluminum and humic complexes. In case of aridisol, which is mostly found in case of arid region, you can see the major characteristics are dry soil, obviously because they are found in acidic region, and it is characterized by ochric epipedon. If you remember the ochric epipedon, it is a light color epipedon which is devoid of organic matter. So, obviously in the arid soil, when there is a high amount of temperature, most of the organic matter will be oxidized. So, there will be formation of ochric epipedon, and of some time there will be argillic or natric horizon. Entisols are the most young soils, and they have little or profile development, and only ochric epipedon is common. And obviously jelly soils are basically found in very cold climate or cold regions, and obviously they are characterized by permafrost. When there is a permafrost condition, and permafrost means when the soil is frozen for most part of the year, then it is called a permafrost condition. And histosol, as the name suggests, hist means it is showing the fibrous characteristics. So, as the name suggests, it is composed of peat or basically peat type of soil, a peat or bog, which contains greater than 20% of organic matter. Inceptisols is an embryonic soil with few diagnostic horizon. It is little bit developed than that of entisol. Mollisols, which contains mollic epipedon with a high base saturation, which this is the basic characteristics of mollic epipedon, and they are basically dark in color. Oxysol, they are characterized by the presence of oxic horizon, and they do not have any argillic horizons, and they are highly weathered, and because they develop in warm and humid climate as a result of intense weathering. Altisols are spodosols are spodic horizon, which commonly spodic horizon commonly with iron and aluminum oxides and humus accumulation. In the spodic horizon, as you remember, there will be elevation of iron and aluminum, as well as some iron and aluminum oxides and humic matter from top of the profile to the bottom of the profile. So, that is this spodic horizon is present basically in spodosol. Altisol, they have low base saturation. These are also highly weathered soils. And finally, vertisols, which has very these soils are having high swelling type of clays, and they produce deep cracks when soil is dry. And we will discuss, I am just giving you a basic overview, and then we will discuss all of them one by one. So, this slide gives you an idea that how soil taxonomy is based on the measurable soil properties, and each category, either it is broad category or specific category, is based on some measurable soil property. So, this slide shows how different soil order forms depending upon degree of weathering and soil development. So, as you can see, when there is entisol is the starting point, because it is recently developed with poor horizon development, and degree of weathering is very slight, and as we go from slight to intermediate degree of weathering, and from intermediate to strong degree of weathering, you will ultimately oxysol is forming. And obviously altisol, spodosol, these are also highly weathered soils. And obviously, what are the different conditions which are needed for development of this individual order, you can see. For example, when there is a starting point entisol and very cold and permafrost condition, obviously there will be formation of jelly soil, as I have already told you in the last slide. When there is a deep accumulation of organic materials, wet conditions, obviously in peat, peat type of parent material, then we call it histosols. And when there will be volcanic mild weathering and volcanic ejecta is there, then we will be calling it andisols, because they are forming in volcanic area. So on so forth, you can see in this slide it is showing that how, depending upon the weathering intensity, one soil order changes from relatively less mature to relatively highly weathered soil orders. So, now one question students always have that in their mind, that how to remember these 12 soil orders. It is always a not easy task to remember all the 12 soil orders. So, there is a simple way to remember these 12 soil orders, and you can remember this name of all the 12 soil orders with a by remembering this thing that is called a Wagami house. Now, this basically shows all the 12 orders, the starting of all the 12 orders in a concise form. How? So, let us see. So, this A basically stands for example, Aridy sols. This V, vertisols. This A, andisols. G, jellysols. A, alphisols. M, mollysols. I, inseptisols. H, histosols. O, oxysols. U, altisols. S, spodosols. E, antisols. So, if you remember this thing, it will be easier for you to remember all the soil orders. Okay. So, let us see in more details about the individual soil order. So, let us start with the most young soil order, that is antisols. Obviously, as you can see the pictures, there is no clear horizon development. So, it is recently developed mineral soil with no horizon, no diagnostic horizon. You cannot see any specific diagnostic horizon, and obviously there will be low degree of soil development due to less time, because they are young in nature, and obviously they occurs in all states of India, especially in the Indo-Gangetic region. So, this is an example of antisols. The relatively more mature soil is called inseptisols, because the soils, these soils, are in the early stage of development, and they may have one or more diagnostic horizons like cambic, umbic, or molic, and then this is umbric, actually it is umbric, and then so it should be read as umbric. So, one R is missing, and molic is there. So, it does not these soils do not have any argillic horizons, because they are relatively immature, and finally they are found throughout the India, and they are very important soils. So, this is the these are the characteristics of inseptisols. Andisols are developed from the volcanic ash, and they are dark colored soil with low bulk density, and they are not generally reported in Indian condition or India. The next one is jelly soils. They occur in cold regions, especially in the Arctic and Antarctic regions or high mountains. And the principal defining feature of these soils is the presence of permafrost layer. And the permafrost layer, when the soil is frozen for most part of the year, and it is basically not reported in India, but may occur in some snow covered Himalayan regions. Histosoil, as the name suggests, organic matter rich more than 20% soils with PT horizons under permafrost water saturated environment. This is called, or in other words, when you see the histic epipattern. So, when the presence of histic epipattern is evident, then it is obviously in histosoils. Aridisols, as the name suggests, occurs in arid climates, arid and semi-arid regions. Soils are dry for most part of the year. Salt accumulation at surface or subsurface occurs due to the forming salic, gypsic and calcic horizon, found in western and northwestern part of India, especially in Gujarat and Rajasthan area. Vertisols are more than 50 centimeter thick, black colored and other black colored soils, and they have a special characteristics. They can swell when moist and shrink on drying, which includes deep cracks and gilgai relief on or intersecting slicken slides. And they have got high clay content, more than 30% of clay content with smectite type of minerals. We will discuss smectite type mineral later on. And basically they occur in peninsular India, and this type of soil you can find in Maharashtra region of India, especially the black color soil are present, and these soils are very good for cotton cultivation. So, you will see that in this type of soil wide cracks are formed, So, in this soil you will see that in this slide, these soils basically you will see deep cracks are basically formed, wide and deep cracks, as you can see here, due to the dry season in the surface layer, and surface debris can slow off into these cracks and move to the subsurface soils. And when the rain comes, water can move quickly into the lower horizons, but the cracks are soon sealed, making the soil relatively impervious to the water. So, this soil basically shows, we call it shrink and swell property. So, in the dry season, when there will be no water, they will form wide cracks, and during the wet season, when the water enters, it will seal those cracks, and ultimately the soil will swell. So, this type of characteristics is a very important characteristics of vertisols. And let us stop here, and from next lecture we will be continuing from here. We will be continuing from vertisols, and we will be finishing off all other soil orders. Okay. Till then, thank you.